Here we have the displayed formula for pentane, and this is the structural formula. This molecule is methylbutane, and this is its structural formula. Notice both molecules have the same molecular formula, C5H10. However, they both have different structural formulas. These molecules are known as isomers. There are two main types of isomers: structural isomers and stereoisomers. Structural isomers have the same molecular formula but different structural formula. And stereoisomers have the same molecular and structural formula but different spatial arrangement of atoms. Okay, there are three types of structural isomers: chain, positional, and functional. And two types of stereoisomers: EZ or cis strands and optical. In this video, we're going to be focusing on structural isomers. Okay, let's start with the first one, chain isomer. So here we have pentane, and this is the skeletal formula for pentane. 5 carbons, so you can see there are 5 points. Here we have methylbutane, and this is its skeletal formula. Notice how both molecules have the same molecular formula, C5H10, however, they have different chains. Even though they have different chains, they still have the same functional groups, as in they are still both hydrocarbons. And it's not just these two, there's one more. Here we have dimethylpropane. This is another chain isomer of C5H10. Okay, let's move on to positional. So here we have chloropentane, or we could say 1-chloropentane, and this is the skeletal formula. Now we've moved it along to the second carbon, so we have 2-chloropentane, and this is the skeletal formula. So again, they both have the same molecular formula, and they also have the same chain length, 5 connected carbons in a row. However, what is different is that we've moved the position of the functional group. In this case, the halogen has moved from carbon 1 to carbon 2. Again, this is not the only example. We could also have 3-chloropentane. All three of these molecules have the same molecular formula, C5H9Cl, and also the same chain. However, the position of the functional group has changed from carbon 1 to 2 to 3. Another place that we have positional isomers are in alkenes. On the left, we have pent-1-ene, and the second one is pent-2-ene. Notice how both of them have the same chain length. However, the double bond has moved from carbon 1 to carbon 2. So this is a positional isomer. Okay, let's move on to the last one, functional. Now for this, there are some examples that you just have to memorize, and hopefully you can recall them in the exam. So over here we have propanal, which is an aldehyde, and here we have propanone, which is a ketone. Now notice, all I did is I moved the double bond and I completely changed the functional group. So this is what functional isomers are. By moving the atoms around, we create a different functional group. Also, it goes without saying that they both have to have the same molecular formula. Here we have propanoic acid, which is a carboxylic acid. And over here we have methyl ethanoate, which is an ester. Again, they both have the same molecular formula, but we have two different functional groups. So another example is carboxylic acids and esters form functional isomers. Here we have but2-ene, which is an alkene, and this molecule is called cyclobutane, which is a cycloalkane. Both have the same molecular formula, C4H8, but they are two different functional groups. One more. So over here we have propanal, which is an alcohol, and this molecule is called methyl ethyl ether, which is an ether. Now, in most exam boards, you don't have to name ethers. However, you do need to know that they exist. Again, both molecules have the same molecular formula, C3H8O, but they are two different functional groups. Okay, so those were the 4 examples for functional isomers. Now, one final point. Don't confuse an ester with an ether. They might look quite similar, however, what gives it away is that an ester has a carbon double bond O, whereas an ether does not have one. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.